When considering electrical conductors, aluminum is frequently used due to its lower cost and lighter weight compared to copper. For a 300-foot 100-amp subfeed, National Electrical Code guidelines typically suggest using number 2 aluminum conductors. While aluminum is suitable for the main conductors, it's generally recommended to still use a copper ground conductor. Copper is a better conductor of electricity and exhibits superior corrosion resistance, providing a safer path for electrical faults to discharge. There are several advantages to using aluminum conductors. Firstly, the lower cost of aluminum makes it an attractive alternative to copper, especially for long runs. Secondly, aluminum is significantly lighter than copper, which can ease handling and installation, particularly in extensive projects. Thirdly, aluminum demonstrates good corrosion resistance in many environments, making it suitable for outdoor applications. However, there are also disadvantages to consider. Firstly, aluminum has lower conductivity than copper, necessitating larger conductors to carry the same amount of current. Secondly, aluminum is more brittle than copper, making it more prone to damage during installation and handling. Thirdly, aluminum experiences more expansion and contraction than copper with temperature changes, potentially leading to loose connections over time. To ensure safe and reliable installations with aluminum conductors, certain best practices should be followed. Firstly, always use approved aluminum conductors and fittings that meet industry standards. Secondly, adhere to proper installation techniques, carefully tightening connections to prevent loosening and corrosion. Thirdly, apply antioxidant paste on all aluminum connections to prevent oxidation, which can increase resistance. Fourthly, provide adequate slack in the conductors to accommodate expansion and contraction due to temperature variations. When installing aluminum conductors, it's important to select the appropriate wire size based on the ampacity requirements and the National Electrical Code guidelines. For a 100-amp subfeed, number 2 aluminum conductors are typically sufficient, but consulting the relevant NEC tables is crucial to ensure compliance. The ground conductor plays a vital role in electrical safety by providing a low impedance path for fault currents to return to the source. A copper ground conductor is preferred due to its higher conductivity and resistance to corrosion, ensuring effective grounding. When making connections with aluminum conductors, it's essential to use connectors specifically designed for aluminum to prevent galvanic corrosion. These connectors are typically made of aluminum or are bimetallic, with a coating that prevents corrosion between the aluminum conductor and the connector. Proper torque is critical when tightening connections to aluminum conductors. Under-tightening can lead to loose connections and increased resistance, while over-tightening can damage the conductor. Always use a torque wrench and follow the manufacturer's recommendations for the correct torque values. Regular inspection and maintenance are necessary to ensure the long-term reliability of aluminum conductor installations. Check for loose connections, corrosion, and any signs of overheating. Retighten connections as needed and replace any damaged components. The National Electrical Code provides comprehensive guidelines for the safe installation and use of aluminum conductors. Familiarize yourself with the relevant NEC articles and tables to ensure compliance with local regulations. When working with electrical conductors, always prioritize safety. To energize the circuit before making any connections and use appropriate personal protective equipment such as gloves and eye protection. In summary, aluminum conductors offer a cost-effective and lightweight alternative to copper for electrical installations. However, it's essential to understand the advantages and disadvantages of aluminum and follow best practices to ensure safe and reliable performance. A copper ground conductor is generally recommended for added safety, and proper installation techniques are crucial to prevent corrosion and loose connections. Always consult the National Electrical Code and local regulations to ensure compliance with applicable standards. The selection of conductor material, whether aluminum or copper, depends on a variety of factors including cost, weight, conductivity, and environmental conditions. Aluminum is often favored in applications where weight is a significant concern, such as in aircraft or overhead power lines. Copper, on the other hand, is typically preferred in applications where high conductivity and corrosion resistance are critical, such as in electronic devices and underground wiring. The ampacity of a conductor, which is the maximum amount of current it can carry safely, is determined by its size, material, and insulation type. The National Electrical Code provides tables that list the ampacity of various conductors under different conditions. When selecting a conductor size, it's essential to consider the ampacity requirements of the circuit and the ambient temperature. Higher ambient temperatures can reduce the ampacity of a conductor, requiring a larger size to maintain safe operation. The voltage drop in a conductor is the decrease in voltage from the source to the load. Voltage drop can be caused by the resistance of the conductor and the current flowing through it. Excessive voltage drop can negatively impact the performance of electrical equipment, so it's important to select a conductor size that minimizes voltage drop. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. The insulation of a conductor protects it from physical damage and prevents electrical shock. Different types of insulation are available, each with its own temperature rating and resistance to environmental factors. The selection of insulation type should be based on the application and the environmental conditions. For example, conductors installed in wet locations should have insulation that is resistant to moisture. When splicing or terminating aluminum conductors, it's essential to use connectors that are specifically designed for aluminum. These connectors are typically made of aluminum or are bimetallic, with a coating that prevents corrosion between the aluminum conductor and the connector. It's also important to use an antioxidant paste on the aluminum conductor before making the connection to prevent oxidation, which can increase resistance. Proper grounding is essential for electrical safety. The ground conductor provides a low impedance path for fault currents to return to the source, tripping a circuit breaker or fuse and preventing electrical shock. The ground conductor should be sized according to the National Electrical Code and should be connected to a grounding electrode system such as a ground rod or a metal water pipe. Electrical codes and standards are developed and maintained by organizations such as the National Fire Protection Association and the International Code Council. These codes and standards provide guidelines for the safe installation and use of electrical equipment and wiring. It's important to be familiar with the applicable codes and standards in your area to ensure that your electrical installations are safe and compliant. Continuing education is essential for electricians to stay up to date on the latest technologies, codes, and standards. Many organizations offer training courses and certifications for electricians, helping them to enhance their skills and knowledge. By investing in continuing education, electricians can provide their customers with the highest quality of service and ensure the safety of electrical installations. When working with electricity, always prioritize safety. To energize the circuit before making any connections and use appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Aluminum conductors offer a viable alternative to copper in many electrical applications, providing cost savings and weight reduction. However, it's crucial to understand the properties of aluminum and follow best practices to ensure safe and reliable installations. A copper ground conductor is generally recommended for enhanced safety, and proper installation techniques are essential to prevent corrosion and loose connections. Remember to consult the National Electrical Code and local regulations to ensure compliance with all applicable standards. The choice between aluminum and copper conductors often comes down to a balance of cost, performance, and application-specific requirements. While aluminum offers a lower initial cost, copper's superior conductivity and corrosion resistance can translate to long-term benefits in certain situations. Understanding the trade-offs between these materials is essential for making informed decisions about electrical wiring. The NEC provides detailed guidance on the proper sizing and installation of both aluminum and copper conductors. These guidelines are designed to ensure that electrical systems operate safely and reliably, regardless of the conductor material used. Staying informed about the latest NEC updates and best practices is crucial for all electrical professionals. Grounding is a critical aspect of electrical safety, and the NEC provides specific requirements for grounding systems. A properly grounded electrical system helps to protect against electrical shock and minimize the risk of fire. Whether using aluminum or copper conductors, ensuring a robust and effective grounding system is paramount. Electrical connections are often the weakest point in any electrical system. Poorly made connections can lead to increased resistance, overheating, and even fires. When working with aluminum conductors, it's especially important to use connectors that are specifically designed for aluminum and to follow proper torque specifications. Regular inspection and maintenance of electrical connections can help to prevent problems and ensure the long-term reliability of the system. As technology advances, new materials and techniques are constantly being developed for electrical wiring. Staying abreast of these innovations can help electricians and engineers to design and install more efficient and safer electrical systems. Whether it's the use of new types of insulation or the development of more advanced connectors, continuous learning is essential for staying ahead in the electrical field. In addition to the technical aspects of electrical wiring, it's also important to consider the environmental impact of the materials used. Copper mining and processing can have significant environmental consequences, and the use of aluminum can help to reduce the demand for copper. By making informed choices about conductor materials, we can help to minimize the environmental footprint of our electrical systems. The safety of electrical workers and the public should always be the top priority when working with electricity. Following proper safety procedures, using appropriate personal protective equipment, and staying informed about the latest safety standards are essential for preventing accidents and injuries. A commitment to safety is a hallmark of a responsible and professional electrician. Aluminum is also susceptible to galvanic corrosion when in contact with the similar metals in the presence of an electrolyte, like moisture. Therefore, special connectors and installation practices are necessary to prevent this type of corrosion. These practices often include using bimetallic connectors that are designed to join aluminum to copper without causing corrosion and applying a corrosion-inhibiting compound to the aluminum conductor before making the connection. The National Electrical Code also specifies the types of connectors that are suitable for use with aluminum conductors and the proper methods for installing them. In addition to galvanic corrosion, aluminum conductors can also be affected by oxidation. When aluminum is exposed to air, it forms a layer of aluminum oxide on its surface. This layer of oxide is a poor conductor of electricity and can increase the resistance of the connection. To prevent oxidation, it is important to use an antioxidant compound on the aluminum conductor before making the connection. This compound will help to prevent the formation of aluminum oxide and ensure a good electrical connection. The ampacity of aluminum conductors is also affected by temperature. As the temperature of the conductor increases, its ampacity decreases. This is because the resistance of the conductor increases with temperature, which causes it to generate more heat. The National Electrical Code provides tables that list the ampacity of aluminum conductors at different temperatures. When selecting a conductor size, it is important to consider the ambient temperature and the expected operating temperature of the conductor. Voltage drop is another important consideration when selecting a conductor size. Voltage drop is the decrease in voltage from the source to the load. Excessive voltage drop can cause equipment to operate inefficiently or not at all. The amount of voltage drop in a conductor depends on the length of the conductor, the current flowing through it, and the resistance of the conductor. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. When selecting a conductor size, it is important to consider the voltage drop and choose a conductor size that will minimize it. The weight of aluminum conductors can also be a factor in some applications. Aluminum is lighter than copper, which can make it easier to install and support. This is particularly important in long runs or in applications where weight is a critical consideration. The cost of aluminum conductors is typically lower than the cost of copper conductors. This is because aluminum is more abundant than copper and is easier to mine and process. The lower cost of aluminum conductors can make them an attractive option for many applications. The availability of aluminum conductors is generally good. Aluminum is a widely used metal and is readily available from most electrical suppliers. The ease of installation of aluminum conductors can vary depending on the application. Aluminum conductors are typically easier to install than copper conductors because they are lighter and more flexible. However, aluminum conductors require special connectors and installation practices to prevent corrosion and ensure good electrical connection. The durability of aluminum conductors is generally good. Aluminum is a strong and durable metal that can withstand a wide range of environmental conditions. However, aluminum conductors are more susceptible to corrosion than copper conductors and require special protection in corrosive environments. The safety of aluminum conductors is comparable to the safety of copper conductors. Both aluminum and copper conductors can be used safely if they are installed and maintained properly. However, aluminum conductors require special connectors and installation practices to prevent corrosion and ensure good electrical connection. The reliability of aluminum conductors is generally good. Aluminum conductors can provide reliable service for many years if they are installed and maintained properly. However, aluminum conductors are more susceptible to corrosion than copper conductors and require special protection in corrosive environments. The performance of aluminum conductors is generally good. Aluminum conductors can provide comparable performance to copper conductors in many applications. However, aluminum conductors have a lower conductivity than copper conductors, which means that they will have a higher voltage drop for the same current. The environmental impact of aluminum conductors is generally lower than the environmental impact of copper conductors. Aluminum is more abundant than copper and is easier to recycle. The life cycle cost of aluminum conductors is typically lower than the life cycle cost of copper conductors. This is because aluminum conductors are less expensive to purchase and install and require less maintenance.